Hey guys, welcome back. So, we are now moving on to what is arguably the hardest algorithm to understand, which is a bubble sort. Um, and the point in a bubble sort is basically to put the stuff inside of our array into ascending, going up, or descending, going down order. Um, it's not super tricky, but it's probably the most complex out of the ones that you have to learn. So if you're aiming for your A's and A stars, you need to know how to do a bubble sort. So how do we do it? Well, let's say, for example, I have some cards, and the cards are these. Let's assume 1 is an ace and 11 is a jack. I'm not going to put them as ace and jack because it's harder to sort. And I want to put them into the correct order. So I want to start from 1 and go up to 11. So the tricky thing about bubble sort is that there are multiple ways to do it. Now, generally speaking, I would argue that the best way to do it, and sometimes the clearest way to remember it, is going to be while, oh dear, for with an if inside. Okay, so we're going to have a while for if. However, in the exams, I've seen it as for if. So these loops can be switched around into different ways. And I'll try and show you both today, but let's start with while for if. So I'm actually going to not start with a while, I'm going to start with for. And you'll see hopefully the reason for that in a moment. So the for and the if are maybe the sort of base of the bubble sort, and we repeat that process with the while until we get into a stage that we want. So what I want to say is for x in range, I'm going to start from 0 and I'm going to go to the length of my array. 1, 2, 3, 4, 5. But I'm not going to go to 5. I'm going to go to 5 minus 1, which obviously is 4. Now again, I'll come back and explain why exactly in a moment, and this is maybe the really tricky thing about bubble sort. There's a whole bunch of stuff going on. So with bubble sort, I take this number and this number, and I compare them together. Now, if you are not sure, if you're completely new to bubble sort, you want to go on to CS50 from Harvard and see how Doug Lloyd does it, because he's amazing. Okay, so if you're completely new to the theory, again, we're just focusing on how to write the algorithms today, not how to explain them. So I'm going to take this number and this number, and if this number is bigger than that number, I want to swap them. And then I'm going to do the same with the next two numbers. So, and then the same with the next two numbers, and the same with the next two numbers. So I want to say if x, that's my 5, sorry, if cards x, that's my 5, is greater than this one. So what would you call this? If this is x, then this is going to be cards x, oops, wrong x plus 1. So if cards x is bigger than this one, then I want to swap them. And then we get into how do we swap. Okay, because swapping is the tricky bit. How do I write this? If the card on the left is bigger than the card, oh for goodness sake, card on the right. Okay, so then I want to swap. And swap is where people get a little bit confused. So we're going to have a variable called temp. Now, we can start off our temp as none, which is empty. Doesn't have anything in it. It's just a blank space that I'm going to use it for at a later date. So I'm going to take, now it doesn't matter which way around you do it. People do it in different ways. It just depends on what feels natural to you. But I'm going to take this number and I'm going to save it in the temp. So I'm going to say temp equals And that number is cards X. So I'm going to put 5 into temp. Okay, then I'm going to move my 1 onto the 5. And that's going to erase the 5. So that's why I've saved 5 in the temp. Otherwise I have 1, 1, and I've lost my 5. Okay, so I want to say that cards X equals cards X plus 1. So this one becomes equal to this. So let me just put it underneath so you can see what's happened here so far. Okay, so we've got temp, which is now equal to cards X, which is 5. And then we've said for our array that 1 is going to be in the first position because we've said that cards X equals cards X plus 1. And that means 1 is still in the second position. And then we've got 10, 11, and 4. Okay, so we've ended up with 2 1s, which is not what we want. So this one is the one that's wrong. So what do we need to replace this one with? Well, in this case, we want to replace cards X plus 1 with the temp. So we're going to write over that and change that to the 5. So all we've done is swap these two values around, and we've done it using this idea here. Okay, so this gets very useful as we go along. It doesn't matter what you're doing, whether it's this algorithm or others, and I guess that's why we're learning it. This idea of swapping is quite useful. Okay, now if I run through my array, and let's say I print my array out, you'll see that we've not actually managed to get everything into the right order. So let's say if I print the cards, then you'll see that it's not completely sorted everything. We'll get 1, 5, well that's better than before, but then we've got 10, 4, 11. So this 4 is still out of place, excuse me, and as is the 10. Now if we had more numbers, you'll see that this would be even worse. Because we only get a small number of numbers, it's not too bad. But realistically, the only thing I know that is sorted is the last number, the 11. The other numbers are perhaps not sorted yet. Okay, so what we want to do is we want to keep repeating this process until the cards are sorted. Now, there are different ways to know if the cards are sorted. We could just do the same number of loops on the outside and inside, and that's how I've seen it done in the exams. But today we're going to look at the while for if. So the while for if is going to say, so we're going to have a variable that says swapped equals true. And now let's get rid of that here, the while for if bit. And I can say while swapped equals, well swapped, that's fine. Okay, swapped equals true, while swapped equals true, same thing. Now at the very start, I then want to instantly switch swapped equal to false. Now, if we were using other languages, we would have a post condition loop. We don't have that in Python, as far as I'm aware. And we want to put our for loop inside of that. So what this is saying is, while there have been no swaps, sorry, that's wrong. While there has been a swap inside of the for loop, then we want to keep repeating this for loop. So basically, what it's saying is, if we cannot move anything in the array into the right place, then it's already correct. So, however, I want to say, if I've done a swap, I want to say swapped equals true. Okay, now hopefully that's not too confusing. Now this is going to be our precondition loop. This is going to be our, what kind of loop? Count controlled loop. And then swap if not in the right place. Okay, so this is while for if. Let's see if that works. Fingers crossed. That's going to get us going. Yay! Okay, now what I would really suggest is that you make a trace table with these numbers and with this algorithm and see if you can prove to yourself why it's working. But in short, we know that the array is not in order, or possibly not in order, if we've had to swap any of the cards. So until we are in a situation where we've not had to swap anything, then we need to keep repeating the check to see that we've swapped everything into the right place. And again, I might try and make a video later, but hopefully a trace table will help you do that. Okay, so that's one possibility. Oh, sorry, and actually, why is this a 4? So I forgot to mention to you guys before, we've got 1, 2, 3, 4, 5 items. So why is it a 4, which is 0 to 3 inclusive? Well, that's because we're using x plus 1. So we're taking this one, which is x, and comparing it to this one. Now, when we get to here, we're taking x, which is 0, 1, 2, 3, and we're comparing it to x plus 1, which is the 4. However, if I did it to 5, then it would take this number and try and compare it to something that isn't inside of the array. So that's going to cause us problems as well. Alrighty, cool. I think I'll save it there, and then I will do it as a next video, and I'll show you how we can change this to be a for loop as well, and maybe some other refinements.